same skill. Simplifying fractions. And just a little bit of kind of a brief history, so that way you understand why we're allowed to do it. If we have 3 divided by 3, what does that equal?
1.
1. So if you have the same number over the same number, a natural number, it's going to equal 1. If I had x over x, that's also equal to 1. Because, Timmy, choose me a number. Any number you like.
6.
6. If I put a 6 in for x there, and I put a 6 in for x there, 6 divided by 6,
It's still 1.
still 1. If I chose 8, 8 divided by 8, still 1. So if you have a letter over a letter, it's just equal to 1.
Except 0.
Except 0. Exactly that. So what I'm getting at, if I had this, a binomial, x plus 2, over the same binomial, x plus 2,
It's still going to be equal to
it's still going to equal 1, because it doesn't matter what number you choose for x, it's still going to reduce down to 1. You had chosen 6. If I put 6 here, what would you get on top? 8. If I put 6 down here, you're going to get 8. 8 over 8, 1. So if it's the same number, the same letter, or the same expression, it's all going to just cancel out and equal 1.
And 0 works there.
Yeah, 0 would, if you put that in for x. Yes. So, let me show you an example of what I mean by simplifying expressions. Let's say we have 6 parentheses x plus 5 over 5 parentheses x plus 5. It's a little different than what you've seen. But notice, on top and bottom, what is your common expression?
x plus 5.
So we know those really just equal 1, so they just kind of cancel each other out. So what are you left with on the top?
6.
A 6. And on the bottom?
5.
And you are now reduced. It's just manipulating algebra, seeing if you can manipulate it to simplify it to its lowest
So
form.
it still will give you a improper fraction.
Yeah, and that's fine. You can leave it as improper. If I'm not specific, which I won't be.
Did they cancel each other out?
Because it's just going to equal 1. And we know 6/5 times 1 would still be 6/5. So they just annihilate. And I cannot say that word. They cancel each other out.
Annihilate each other.
If x were 2,
Okay.
so that's 10, but that's still 6 times 10 is 60, and 5 times 10 is 50.
No. If I put 2 there, 2 plus 5 is 7 times 6 is 42. 2 plus 5 is 7 times 5 is 35. But when you reduce it, you'd still get 6 over 5.
Oh, I see.
Yeah, so
So it's a trick.
yeah, the way you were looking at it, you were multiplying. But they will cancel each other out if they're the same. Let's try this one.
You're going to reduce, aren't you?
What could I cancel?
You can cancel the x minus 1.
Okay, that's your common expression. So they're gone. And you're left with 3 over 6.
1/2.
Okay, how'd you get there?
2.
By
Goes
what?
into 3.
By 3. So you can keep going. I could divide the top and the bottom by 3. Because you want to go as far as you can. On top, 3 divided by 3 would give you 1. 6 divided by 3 would give you 2. So it reduced to 1 here. Okay. Now notice, on both of these examples, I already took the GCF out for you. These are GCFs that are sitting out here on the ends. That's not going to happen every single time. That's just being nice at the very beginning. Now let me give you one where we actually need